Hi and welcome to another one of the series of the Printtable S series build. Now on this edition I'm going to start talking a bit about the wiring harness. Now this is obviously for the Printtable S series. Uh, Here's the main harness here, and essentially what we're doing is we're taking things up from the underneath of the board, coming all the way up through to the X motor and to the X end stop, and then onwards to the actual print head itself. Now it's on the print head is where we need most of the wiring. So certain things that we're doing is we're using Cat5 cable, which essentially normal networking cable, but we're looking for not solid core, we're looking for stranded copper internal wire. Okay, and because everything that we're running is essentially on a 12 volt and we're not drawing many amps in total, the main thing is going to be the heater on the hot end itself. But when it comes to that, we are going to be joining up two separate pairs in order to split the load down the wires. And essentially having the wires also coiled round, so folded round each other, that all helps as well with any interference. Now, the reason why I've chosen the Cat5 cable is the current and the ampage is adequate enough to carry the load that we're doing, but also the fact that I want the thinner wire, or the wires, to be as thin as possible whilst still being safe, and able to pass it through the energy chain itself. Now, in an ideal world, I would want to keep the wire all together in its cabling and casing, but the reality of it is it's just not possible without starting to increase the size of the energy chain. I've tried some different sizes on the energy chains, but the reality of it is I find this one here, which is it's labelled up as 7x7, which internally is 7mm by 7mm. That's what the 7x7 means. I'll provide a link on the video, or at least in the description, on where you're able to purchase this energy chain from. Now, normally it's sold in 1 meter length, and unfortunately we need just over 1 meter in order to do the entire energy chain requirements for the Printtable. So you will have to buy 2 lengths, but you know, depending on where you are in the world, you may be able to buy this for as little as $8 or $10 for each piece. So as I say, it comes in 1 meter. I've got this took some of the links out. Now, in terms of links, you're going to want, one of them is going to want approximately 29 links, and then the end on there, and the other is going to want 30 links. So each one of these being a link, you're going to want 30 of those in total, and then the end on there. Now, obviously, there's quite a few cables that we're having to pass through, and as I say, it's just not plausible to be able to pass it through on all of the casing. So we have to then start looking at removing the sheathing off here. Now, as it stands at the moment, I mean, I've been running this cable for quite some time, so I haven't had any issues with any of the cabling breaking or coming out, but we are going to be passing a few extra cables through in case, when we come to wire things up, we ever do get a problem with the wiring. Now, I must stress at this point, the wiring of any 3D printer is essentially the part that you must make sure that you get right. You must ensure that you're not getting any bare cablings touching each other, and you must make sure that you do continuity tests on all of the wires prior to you using it. In fact, part of this build, what we're going to do is we're just going to pass all the wires through, and then when it comes to doing the final wiring, we'll do continuity tests to be able to match them up then from each end, and make the decision as to what wires are going to be doing what for what reason, whether it be a motor, whether it be an end stop, whether it be a fan at the hot end stage, or a part walling fan, or even the thermistor. So for the time being, we're just going to talk you through actually assembling part of the wiring harness ready for the assembly into the Printtable itself. So in total, we need about 28 wires. Now, because there's 8 wires, 4 pairs traditionally in Cat 5e cable. So this is why we're going to use some for redundancy or in case you have any breaks or this, that, and the other. So we're going to strip out 4 lengths of approximately 2.8 meters. So 4 individual lengths of your Cat 5 cable. So what you want to be doing is measuring from end to end 2.8 meters, yeah, or 2,800 millimeters, and you want to be measuring that out 4 times. And so then when you've got your 4 lengths, then what you need to be doing is start stripping the actual outer casing off. Okay, so that's all the core stripped off it, all the outer casing stripped off it. I've put some insulating tape around to hold all the wires together, and then I've continued that until I get a little bit of a point. So that bit there is just actually insulating tape the wires end about here. And the reason for this is to give that a little bit more of a turn, and then I'm going to force that into a bit of PTFE tube, and then using a bit of masking tape I'm going to wrap that round. Same again, try and get that as tight as I can. I really want to get it stuck well onto the PTFE tube. I mean, we know PTFE tube itself is quite slippy. So it's really as tight as I can. And the reason for that is to start threading it through the actual energy chain itself. And the energy chain is the one that's got the 29 links on it, so the shorter one out of the 2. And we're going to start with the end where we've already got the actual end piece put on and start threading that through. Just catching on the links a little bit there as I'm forcing it through, and then carefully try and pull the wires through without actually getting them to slip out. So I'll just force it along a little bit. So it can be quite tricky. You might have to do this 2 or 3 times if you start pulling the wires off and things like that, because it is quite stiff to get all of the wires through. What I found is sometimes just best as you try going through, just give them a little bit of twist just to make sure that you're getting rid of any resistance that could be here. Go for that, and unfortunately I'll pull that back off, so I'm going to give that another go. Okay, so after a bit of tedious gentle persuasion, I've managed to get the wires through the first one. Now from this end here to here, you want around about 740 millimeters of cable left through. So using my rule, I'm going to put that on the 740 mark and just keep pulling that through, checking that and guiding the wire through as I'm doing it. Okay, that's approximately 740. So I've got 740 millimeters of wire now from that end. Now, before I go and carry on and pass it to the second one, I can actually release now 8 of the wires. So I only need 7. 4 are for the X motor and 3 are for the X end stop. But I'm going to pull back 8, so I've got 1 spare wire in case I've got a continuity problem or any problems with any of the wires in the future. It just means that I've built in a little bit of redundancy into the actual wiring harness itself. So I'm just going to pull a couple of pairs back. I think I'll go with a full set, so green and a brown as well, pair. Okay, So I'm just going to thread them back now. Okay, so that's 8 wires pulled back. And like I say, that's going to be doing the X motor and the X end stop. So in total here now, I'm going to take the tape back off because I'll need to redo it to thread it through. So now we've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's 24 wires, 12 pairs, 24 wires in total. I like to say some of them, 4 of the wires are going to be doing the extruder motor itself, 2 of them are going to be doing the thermistor, 4 of them are going to be doing the hot end, and then we need a couple for some fans. We need a total of, depending on how I do the configuration of the wiring on it, I'm not quite decided on this one yet, whether it be 4 or 5 wires for the BL Touch. All it means is I can either give the BL Touch its own earth, or I can piggyback off one of the fan earths in order to do that. So now I'm going to retape those back up, get it nice and tight. And now it's time to go through the threading process yet again. Now this should be a little bit easier because we've got 8 wires now that we're not utilising. So same again, starting with the end, starting with the energy chain which has got the end on. Start passing that through. So you can see there that one's going through a hell of a lot easier because we've not got so many wires passing through now. Okay, now it's at this stage here that we can see how much wire we pass through, and what we want to be doing here is between the 2 black pieces here, we want to be leaving about, if I remember correctly, it's about 10 millimeters, but I'll just double check on there. Yeah, 10 millimeters will do it fine. But what I want to do is I want to ensure that I've got some insulating tape actually within the energy chain itself. So what I'm going to do is first of all is just measure, use my small rule. Okay, that's about 10 millimeters there. So what I'm going to do now is just pull them ones out of the way for the moment. Just to pull that back around about 20 or 30 mil. Get my insulating tape, get them nicely bunched up together. And actually nice and tightly get them what we're trying to do is get that tape nicely wound round together, and then obviously we'll join them back in and we'll just pass them through. They're giving about 2 centimeters, 20 millimeters from the end. So rather than go the full 10, we'll just pull them back a little bit and make a nice, tight, neat wiring harness. so everything looks right. So I'm just going to continue now just to put that tape around. And done. You look on one of the harnesses I've already done there. So I've got that joint, I've got the motor wire there, and then I've also got the end stop wire there. I'll just put a little bit of heat shrink and protector around these so I can pull that nice and close up. So that is the first part of creating the wiring harness, and I wanted to get that out of the way now, ready, so when we do start going into the build and putting the motors on, we've got this piece ready to start actually passing it through onto the connectors and stuff like that. From here onwards, this now goes all the way down to the board. So essentially what you can do is what I've done on this one is I've just got some braiding and I've just put the braiding on. Ignore these two wires now which I've got in here, because we won't be utilising these wires off on the main harness. This one will just continue all the way down, so you can braid that all the way down, ready to go onto the board itself. Okay, so that'll be in the next videos as we continue through the build. But obviously, I just wanted to give some people, well, just really wanted to give the builders, give the people building the print table some guidance as to the wiring and how we build up the main wiring harness for the print table. So just to recap, we're using Cat5 E cable. It has to be the stranded type cable, so not solid core. In total, you're going to be cutting 4 lengths, which are 2.8 meters, 2,800 millimeters, yeah, in length. So you want 4 of those. And what you do is you cut the outer sheathing off. I'll show you on here. Piece I've got. So you want to be cutting the outer sheathing off and then putting it through the 2 pieces of energy chain. One of them's got 29 links on with the end. The internal measurements of this are 7mm by 7mm, and the other one has got 30 links on with the end. And that's what we need to do to get to that stage. Hope you've enjoyed it, and then obviously we'll carry on to some of the next videos on continuing to build the print table. Thank you.